Texturology. Image to PBR material with AI.
In the world of 3D, our workflow is our sanctuary. But too often, we're forced to leave it, breaking our creative flow for external tools. Today, we change that. Welcome to Texturology, where we transform the mundane into the magnificent, right here inside Blender. Let's see how it works. Here is the Texturology interface, designed to be intuitive and accessible. We'll focus on the Maps to Generate panel. This is where we select the essential texture maps for a physically based rendering, or PBR workflow. We can generate a base color, which is the texture's pure color, free of any lighting information. A normal map to add the illusion of complex surface detail, like cracks and bumps, without adding extra geometry. And a roughness map, which controls how light reflects, defining whether a surface is shiny or matte. For added realism, we can also create a height map for displacement, an ambient occlusion map for subtle contact shadows, and a curvation map. The curvation map is incredibly useful for procedural workflows, as it highlights edges and crevices, perfect for adding effects like wear or dirt. But let's not just talk theory. Now, let's put it into practice. We click Load Image and choose our subject, a photograph of stone pavers from Texture Ninja. Notice the complex real-world lighting, the highlights, the shadows. As you can see, it has natural, uneven lighting, a common challenge when working from photos. Our mission is to intelligently convert this into a set of clean, usable PBR maps in order to contribute to the ultra-realism of the best workflows in 3D. We'll generate the full suite of maps. The settings are powerful but intuitive. As we mentioned in the documentation, the normal map has two options, each with its own particular capabilities. But in most cases, we recommend using the second option, which is the default. In the case of the height map, something similar happens. However, the second option is not provided directly by artificial intelligence, but thanks to it, that is, it uses the normal map to generate the height map. Now, I'll just adjust our curvature's blur radius to small for sharper edge detection. With our configuration set, we're ready. A single click on Generate Materials ignites a symphony of algorithms. The auto now processes the image, and you can track its progress in the status bar at the bottom. In just a moment, the process is complete, and the generated textures gallery appears. Let's review the results. First, the base color. Notice how the AI has successfully removed the directional lighting and shadows, giving us a clean, flat albedo that will react correctly to any lighting in our scene. This works perfectly when the shadows and lighting are natural, that is, when the image has not been filtered or color post-processed. Next, the normal map. Look at the high-fidelity detail captured here. It gives the surface a tangible sense of depth. The roughness map is just as effective, correctly identifying the different surface properties of the stone and the grout. The height map provides excellent displacement information. And finally, the occlusion and curvature maps, which provide the subtle data needed for advanced texturing. The effects that can be created with these two maps are only at the texture level. Since ambient occlusion and curvature maps are not calculated at the level of the model to which the material is applied, but rather in the material itself and its physical characteristics, which were inferred using AI. From a single photo, we now have a complete, production-ready material. What time to be alive? A modern texturing pipeline demands flexibility. When we click Export Textures, we're not given a one-size-fits-all solution. Texturology understands that different maps have different needs. While we can set a global format, we can also dive deeper. We can override these settings for specific textures. For instance, our normal map deserves the full floating point precision of a 16-bit OpenEXR file. We can set that individually, ensuring maximum quality where it matters most, without bloating our other files. But the power of Texturology extends beyond generation. In the advanced AI features, we find tools for enhancement and repair. Let's begin with AI upscaling. We'll load a new image, a 2000 texture of gravel from the button load image or from the default icon folder of the image editor. It's a good texture, but what if our scene requires a close-up? In the AI upscaling panel, we select our image, choose a scale factor of 2x, and click Upscale Image. This isn't a standard resize, which often just blurs pixels. Texturology uses a trained AI model to analyze the image and generate new, plausible detail as it enlarges it. And here is our new 4K texture. Let's compare the original to the upscaled version. The clarity is immediately apparent. The AI has preserved sharp edges and enhanced the fine texture, creating a result that is not just larger, but genuinely clear. This is how you breathe new life into your existing texture library, ensuring every asset is ready for the demands of modern rendering. Now for our final feature, AI inpainting. Every artist has faced this, the almost perfect texture, marred by a single distracting element. For this, we have a photo of sand, beautifully textured, but marked by some unwanted tracks or rocks. We can fix this without ever leaving Blender. As you can see, the texture is uniform in the sense that it is pure sand and is, arguably, monochromatic. This is the type of texture that works with inpainting, which, mind you, does not use AI. We use an advanced example-based texture synthesis algorithm, not a neural network. Although it is not a deep learning model, it uses stochastic techniques and pattern analysis to generate intelligent fills, which is why we present it within our AI features as AI inpainting. In the AI inpainting section, we select our sand image and click Start Mask Painting. This brings us into a dedicated texture paint mode. Our goal is simple: to tell the add-on where the problem is. Using a soft brush, we paint a mask over the tracks. We're not cloning or smudging, we're defining a canvas of what if. We're telling the add-on, I want this gone, and I want you to intelligently rebuild what should have been there. When our selection is complete, we simply click Finish Painting. With our mask ready, we click Apply Automatic Inpainting. The auto now performs its most impressive feat. It analyzes the texture surrounding our mask, the grain, the color, the subtle dunes, and uses that information to synthesize a brand new, perfectly seamless patch. And like a ghost in the machine, the tracks and rocks have vanished. It hasn't just copied another piece of sand, it has generated a unique, contextually aware fill that honors the original texture's character. The before and the after. The imperfection is gone, leaving only the pure, intended surface. This is the power of a fully integrated AI workflow. We've gone from a flawed photo to a flawless texture, ready to be used or to become the input for a new PBR material generation. The possibilities are endless. So there you have it. In just a handful of minutes, we've witnessed a complete creative loop, from raw photo to a full material set, from a low-resolution image to a high-quality asset, and from a flawed texture to a perfect surface. All within the comforting familiarity of Blender. That's the core idea behind Texturology, to empower your creativity by streamlining the technical process. It allows you to stay in your flow and focus on what truly matters, your art. Thank you for watching.
Texturology. Image to PBR material with AI.